So let's have a look at molecular forces and polymers. So the size of a molecule affects the overall strength of the intermolecular forces. Remember, that's just the forces between molecules in a substance. The strength of the intermolecular forces affects the properties of that molecule. So small molecules have weak intermolecular forces, and this means that they have low melting and boiling points. And this is because of this, they're often liquids or gases at room temperature. Small molecules don't contain delocalized electrons, and because of this, they cannot conduct electricity. So one example would be chlorine. It's a small molecule, Cl2, and it's got weak intermolecular forces between its molecules, and because of that, it's a gas at room temperature. Now, as molecules get larger, they attract other molecules with stronger intermolecular forces, and that means that they have higher melting and boiling points than smaller molecules. Now, they don't contain delocalized electrons, so can't conduct electricity. So, for example, sucrose is an example of a bigger electron. It's made up of 45 atoms in total and has the chemical formula C12H22O11. And although it is a simple molecule, its size means that its intermolecular forces are strong enough for it to be solid at room temperature. So which of these has stronger intermolecular forces? Is it bigger or smaller molecules? Now remember, the stronger intermolecular forces go with the bigger molecules. Now the sum of the intermolecular forces between small molecules is small, and the sum of the intermolecular forces between bigger molecules is greater. Now let's have a think about polymers. Polymers are large chain-like molecules that can extend for thousands of atoms, and they are held together by strong covalent bonds between atoms in the molecule, and also weak intermolecular forces between molecules. Because of their large size, polymers they have really strong intermolecular forces between molecules, and they add up to be quite strong. And that means polymers are often solid at room temperature, but they do melt easily because the intermolecular forces are still weaker than the chemical bonds. So to recap that, polymers are large chain-like molecules, and covalent bonds hold together individual molecules within chains. Intermolecular forces hold together atoms from different chains. And a covalent bond involves two atoms sharing one or more electron pairs, and the covalent bonds between the atoms in polymers are strong. Now, intermolecular forces between polymer molecules add up to be quite strong purely because of the large size of the molecules. So which of the following is strongest? Intermolecular forces in small molecules, covalent bonds, or intermolecular forces in large molecules? Well, intermolecular forces in small molecules are very weak. Intermolecular forces in large molecules are stronger, but they're still not as strong as covalent bonds, which are the strongest bonds. Polypropylene is an example of a polymer, and it's made up of many, many repeating units. And because of this, we can show the chemical structure as the simple chemical structure and show it repeated lots of times. So we just show one repeating unit for polypropylene in this example. So we just put 3 carbon atoms with hydrogens attached, and we put brackets around them and put a little N in the bottom corner to show that we have many, many of these repeating over and over again. Now, over the brackets, you also need to know that there needs to be a bond coming out of each carbon across the brackets to make sure you show it's repeating. So the N tells us, if you remember, how many times that monomer that unit has been repeated. And those polymers are made up of repeating units, and because of this, we show their chemical structure as a unit that is represented lots of times. Now, graphite, let's have a think about its melting point. We know from graphite that it's a giant covalent structure, and it's got a higher melting point than methane. So this is because the melting requires you to break the covalent bonds rather than the weak intermolecular forces. Now, what is chlorine? What state is chlorine at room temperature? Remember, that is a gas. And forces between chains in polymers, you've got intermolecular forces, and the bonds within the chains are covalent bonds. What are polymers held together by? Well, we've got strong covalent bonds, and we've got weak intermolecular bonds. In polymers, sections are repeated many times to create chain-like molecules. And with the prefix poly, it usually indicates that there are many of something. For example, polypropene is a polymer. A polygon is a shape with lots of sides, with many sides. And a polyglot, I'm not sure what a polyglot is, but a polyglot also has lots of something.